So we're going to be looking at this integral. It's a more difficult trig sub integral, but it's not too difficult. It's just a standard trig sub. Anytime we see that square root of a squared minus x squared in any form, we're going to use this substitution, x equals a sine theta. And we're going to get our dx to be a cos theta d theta. So we're going to plug that in. We've got a squared sine squared theta by the square root of a squared minus a squared sine squared theta. And we're going to times by dx, which is a cos theta d theta. This term down here is obviously just going to go to the square root of a squared cos squared theta, which goes to a cos theta. So this and this cancel out. And we're left with this integral here, which we know how to do pretty easily. And that's obviously simplified pretty, just only in 2 lines there. So we're going to go with using our double angle formula substitution. So cos 2x is going to be cos squared x minus sine squared x. And through some trig identities, we arrive that sine squared x is 1/2 minus 1/2 cosine 2x. So we're going to factorize that 2 out, and we're going to have, or half I should say, a squared over 2, and the integral of 1 minus cos 2x, which is just going to be, why is that dot there? We'll get rid of that. A squared over 2, integral of 1 minus cos 2x dx, which is obviously just a squared over 2, or not x, apologies, theta. Making too many mistakes here, d theta. So a squared over 2 theta minus a squared over 4 sine 2 theta plus c. We started off at x, so we need to convert back from theta to x using a triangle. So we said sine theta is x over a. So x a as sine is opposite of our hypotenuse. So that means this is a squared minus x squared. That's sine 2 theta. How are we going to do that? Well, sine 2 theta is just 2 sine theta cos theta, which in this case is just going to be 2 x over a times adjacent over hypotenuse, which is a squared minus x squared over a. We get that a squared down here. So we can go ahead and say that our integral then is a squared over 2 inverse sine of x by a minus a squared over 4. We're going to multiply by 2x by a squared times a squared minus x squared. A squared and a squared cancel. 2 and that 4 cancel down to 2. So we end up with a squared over 2 inverse sine of x by a minus x over 2 square root of a squared minus x squared plus c. And that is our final answer.